All right, just for a second, I want you to look around you, wherever you are right now. Think about all the invisible forces that are just filling that space.
I mean, for starters, there's the signal that's bringing this to you right now, right?
Or maybe you can hear music from a car radio somewhere outside. And of course, there's that device in your pocket, the one that connects you to, well, the entire world in a blink. So what do all these things have in common? I mean, they seem so different, but they all share this one single, totally invisible origin.
In fact, they all came from the mind of one person, someone who, with just, a pen and some paper, saw these hidden connections that nobody else could see. And that man's name was James Clerk Maxwell. He was this quiet Scottish physicist who, it turns out, was the architect of our entire unseen, interconnected world. Maxwell was born back in 1831 in Edinburgh, Scotland. And his work, man, it became the bedrock for pretty much everything. Radio, radar, even Einstein's theory of relativity. But to really get a handle on his biggest achievement, we've got to first appreciate just how powerful his mind was. And we're going to start with another one of his brilliant moments. So, before he got around to unifying the fundamental forces of nature, Maxwell looked up to the heavens. He got obsessed with this beautiful but totally baffling problem, the rings of Saturn. See, back then, nobody had a clue what they were actually made of. And this quote, it just perfectly captures how his mind worked. It wasn't enough for him to just know the rings were there. No, he had this deep, burning need to understand how. How could they possibly exist according to the known laws of physics? So, just using pure math, no telescopes, just math, Maxwell proved the rings couldn't be solid and they couldn't be liquid. He figured they had to be made of a huge cloud of tiny, independent particles, each one orbiting Saturn like its own little moon. And get this, his idea wasn't actually confirmed until the Voyager probes flew by more than 100 years later. Just incredible. Okay, so he solved this massive riddle in the heavens. Next up, Maxwell turned to an even deeper mystery, one right here on Earth, the fundamental forces of the universe. You have to understand, back in the 1800s, physics was, well, it was kind of a mess. Scientists knew about electricity, sure. They knew about magnetism, and they knew about light. But they thought of them as three totally separate, unrelated things, each one playing by its own set of rules.
But Maxwell, he suspected there was a hidden connection, a unity. He was the first ever physics professor at the brand new Cavendish Laboratory at Cambridge, a huge deal, by the way. And he took on this absolutely monumental task. He set out to translate every single known experiment on electricity and magnetism into one single mathematical framework.
And what he ended up creating wasn't just, a summary of what they already knew. Oh no. It was a profound revelation about the actual nature of reality itself. Now, his first attempts were dense. I mean, they were filled with these incredibly complex models of gears and whirlpools and all sorts of stuff, trying to picture how these invisible fields might work. It was a total mechanical monster. But then, through this process of just brutal simplification, Maxwell stripped all that machinery away. And what was left was the pure essence of it all. 4 simple, elegant equations. And I'm telling you, to a physicist, these 4 lines are like one of the most beautiful poems ever written. But here's where it gets crazy. The real shock came when he used these equations to calculate the speed of a wave, a ripple, traveling through these newly combined electric and magnetic fields. He crunched the numbers, and out popped a very, very specific number. And Maxwell just froze. He knew that number. He'd seen it before. But where? What on earth was so special about 310,000 kilometers per second? It was the speed of light, the one that had been measured in experiments. The coincidence, it was just too perfect to be an accident. And in that single, staggering moment of insight, Maxwell realized what he'd done. He hadn't just unified electricity and magnetism, he'd stumbled upon the secret of light itself. Light is an electromagnetic wave. What this meant was that Maxwell had just proven that the fire from the stars, the glow from a candle, all of it was just this tiny, visible sliver of a huge, invisible electromagnetic spectrum. I mean, he basically predicted radio waves, microwaves, X-rays, all of it, before anyone even had a clue they existed. But the world, it was busy with its steam engines. It barely even noticed.
Honestly, the math was just too advanced for most scientists at the time. And then, so tragically, Maxwell died of cancer when he was only 48. His grand theory was still just a prophecy on paper. For 8 long years, those equations just sat there, dormant. But then, over in Germany, a physicist named Heinrich Hertz decided to build an apparatus to go looking for Maxwell's invisible waves. He created a spark, and across the room, a second, totally disconnected spark answered back. The ghost in the machine, it was real. That useless little spark, which is actually what Hertz called it, was basically the birth cry of the modern world. It led directly to radio, to television, to radar, to all the wireless technologies that completely define our lives today. In the end, Maxwell's equations didn't just describe the world, they gave us the tools to rebuild it from the ground up.
And you better believe the greatest minds of the next generation knew it. There's this great story where Albert Einstein was asked if he stood on the shoulders of Isaac Newton, and he replied, "No, I stand on the shoulders of Maxwell." See, it was Maxwell's discovery that the speed of light is constant that completely broke classical physics. It's what forced Einstein to have to rethink everything he thought he knew about space and time.
So let's just end on this morning thought. It's from the physicist Richard Feynman. He argued that if you look at the grand sweep of human history, that single, quiet discovery Maxwell made in a darkened room was way more transformative than all the great wars and revolutions of his time. Think about that. He didn't just explain the light. He gave us an entirely new universe to see.